The second part of chapter 7 deals with logarithms, and this is a topic that we haven't studied before. So here we go, logarithms, get it? I actually took this photo when I was at Glacier National Park, very scenic nature photo. That's about the exact moment when I could pinpoint that I was turning into my mother. So continuing on, the problem that we've looked at when we studied exponential functions was, what if I want to solve this equation where x is in the exponent? Currently, the only way that we know how to do this is if we graph both the left and the right side of the equation and set these equal to each other, found where they crossed, and then I could find the value of x. Well, instead of having to graph this and find the point of intersection, the solution lies within logarithms. So logarithms allow me to solve equations where the variables are in the exponent that we couldn't solve before without a graphing calculator. So what is a logarithm? This is the key thing here. A logarithm is an exponent. So tomorrow in class, let's start class like this. I'd love to say, good morning, students. What is a logarithm? And then you could reply, good morning, Mrs. Meister. A logarithm is an exponent. So what is a logarithm? A logarithm is an exponent. Here's kind of the definition of a logarithm. If I see this right here, this is read log base b of x equals y. So log base b of x equals y. This is true if and only if b to the y equals x. So what I've circled here, these actually mean kind of the same thing. So the base of a logarithm is found right here. That turns out to be the base of your equation. What is a logarithm? Well, a logarithm is, what does this equal? A logarithm is an exponent. So this log here equals y. That means y is the exponent. And then the x value, whatever's in here, that's called the argument. So this means the base is b, the exponent is y, and b to the y should equal the argument, which is called x. Now, this is something we'll talk about later in this section, but b is any positive number except 1. So the base here, this relates back to what we studied kind of the previous days with exponential functions. The base is going to be positive, and it can't be 1, which again, we'll dive into the reasons in the future why that has to be true. Now let's put this to a numerical example. It might make a little bit more sense. If I see this, this is read log base 2 of 8 is 3. So log base 2 of 8 is 3. Verbally, that's what this is saying. And if I see this equation, this means, okay, this number down here is my base, so 2 is my base. What is a logarithm? A logarithm is an exponent. So this logarithm equals my exponent, which is 3. So this essentially means 2 to the third power equals that argument, which is 8. So 2 cubed is 8. Just another way to write this equation. So let's look at an example. Write the following in exponential form. So exponential form, I want a base with an exponent. Well, if I see log base 5 of 625 equals 4, this means my base is 5. What is a logarithm? Well, a logarithm is an exponent. So the 4 is my exponent, and 5 to the 4th should equal my argument, which is 625. So pause the video, give the second one a try, write that in exponential form. So here we go, exact same equation. This is the equation in logarithmic form. This is the equation in exponential form where I have a power equal to the argument, which is right here. So my base is 7. Yep, here's my base. What is a logarithm? A logarithm is an exponent. So whatever that log equals, that's my exponent. And that should equal 1 over 343, which is the argument. Recall that this is the same as this, which is 1 over 343. Now we can do the reverse. So now I'm giving you something in exponential form where I have that base 2 power equals a number. I want you to write these same equations but using logs. So pause the video. Let's see if you can do this in the reverse. So here's the start to both of these. Log, I need a base, so the base is whatever's under your exponent. So that should be the base of each of these logarithms. What is a logarithm? A logarithm is an exponent. So is means equals. These logarithms should equal the exponent. So here the exponent is 3. Here the exponent is 2/3. And then what is left? That should be my argument. So in this case, 216 is the argument. In the second one, 9 is the argument. So here's my base. A logarithm is an exponent. And then kind of that answer, what these equal, that's the argument. Now, let's actually evaluate the logarithm. So I want to know what these logarithms equal. Well, what's a logarithm? A logarithm is an exponent. So on these problems, if I'm looking at the first, this would be read log base 10 of 100. And I want to know what that logarithm equals. So essentially, when I see this, I'd be thinking my base is 10. Well, a logarithm is an exponent. So I want to know what the exponent would be on 10 that would give me out 100. So essentially this is saying, okay, 10 to what power is 100? Well, that should equal 2. So the exponent on 10 would have to be 2 to give you out 100. See if you can take that example and give the other two a try. So here might be my thought process on the next two. Log base 5 of 125 is saying, all right, 5 is my base. What would the exponent on 5 be to give me out 125? That exponent, which is what a logarithm is, would be 3. 5 to the third power is 125. Last one, 4 to what power would give me the square root of 4? So I want to know what's the exponent on 4 that would give me the square root of 4. Well, I mean, recall that the square root of 4 is like 4 to the 1/2 power. So that exponent on 4 would have to be a half. 4 to the 1/2 power would equal the square root of 4. A couple more that we can look at, so maybe pause the video, see how you can do with these. Okay, so first step, I just wrote these from logarithmic form to exponential form. So I want to know, all right, my base is 2. What am I looking for if I'm asking you to evaluate a log? I want to know what the exponent on 2 would be that would give me out that argument of a 4th. Now this one's maybe a little bit tricky, but let me ask you, well, what if this 1 wasn't there? What if I just said 2 to what power is 4? Well, 2 squared is 4. So how would I get the 1 over 4? Well, that would be 2 to the negative 2 power would give me 1 over 4. Recall, if I have a negative exponent, I could bring that to the other side, make it positive. And yep, 2 to the negative 2 power is what should give me out a 4th. Okay, so 2 squared would be 4. 2 to the negative 2 power would give me 1/4. Last, if I evaluate this log, so I want to know 10 to what power gives me the cube root of 10. This is similar to the example on the previous page. Well, the cube root is the 1/3 power. So 10 to the 1/3 power, that would be your exponent on 10, would give you the cube root of 10. Now I actually have an equation where we want to solve for one part. So maybe I'd ask you to find the base or the argument or the exponent. In this case, I want to know what the argument is. So I've given you a logarithmic equation. It would be useful to rewrite this as an exponential equation. So log base 6 of x equals 3. is the same as saying, well, what's my base? That would be 6. What's the exponent? A logarithm is an exponent. My exponent is 3. So 6 to the 3rd power should give me out that argument of x. And then if I just evaluate this, 6 times 6 times 6 is 216. So now I've solved this equation. In order to make this true, x would have to be 216. So now I just have a few more examples involving equations. Let's see if you can set this one up and solve it. Pause the video. So I started with an equation that was a logarithmic equation. It has a log in it. I just rewrote it as an exponential equation. My base is 81. A logarithm is an exponent. 3/4 is the exponent. Hopefully you're getting that now. A logarithm is an exponent. And that should equal the argument. And then if I want to solve this, I guess this just goes back to the last chapter. Break it up. 81 to the 1/4 cubed would be c. A fourth times 3 is 3/4. 81 to the 1/4, or the 4th root of 81, this would just be 3. And then I'm cubing that, so 3 cubed is c. 3 times 3 times 3 is 27. So if I'm solving this equation, if that logarithmic equation is true, c would have to be 27 because 81 to the 3/4 power is 27. Here's another one. Now I want to solve for the base. So if I were solving and setting this up, well, my base now is b. So I don't know the base. What is the exponent? Well, a logarithm is an exponent, so that's my exponent, -5. And b to the -5th, that should equal the argument, which is 32. Now this again goes back to something that we did last chapter. So if I want to undo the -5th power and just get this to look like b to the 1st power, raise each side to the reciprocal power. So the reciprocal of -5 would be -1/5. -5 times -1/5, that would be just 1. So now I have b to the 1st power, or just b, should equal 32 to the -1/5. Well, 32 to the -1/5 would be the same as 32 to the +1/5. Cross the line, change the sign on the exponent. And 32 to the 1/5 would be 2, so your answer would be 1/2. You could feel free to type this into your calculator. 1/2 to the -5th power certainly should give you out 32, which would make this original equation true. So very last example, let's see if you can set this up and solve, finding the value of the base. So pause the video and give this an attempt. All right, so first step, change from the logarithmic equation to the exponential. To get rid of the 3/4, raise to the reciprocal power. 3/4 times 4/3 is just 1. So now I have z to the 1st power. What are we going to do with this one over here? Well, 8 to the 4/3 power, let's break that up. That would be the same as 8 to the 1/3 to the 4th power. And 8 to the 1/3 is 2. 2 to the 4th, 2 times 2 times 2 times 2, or 4 times 4 would be 16. So if I'm solving this equation, z has to equal 16 because 16 to the 3/4 power is 8. And that is an introduction to the wonderful world of logs.